Hi guys, today we're looking at atomic trend 3 out of 4. This is on ionization energy. Probably the most complicated of the periodic trends. We're going to spend 2 days on this one just because there's a bit to cover. So, ionization energy, what is it? Basically, this is the amount of energy it takes to remove an electron from an atom. Okay? So we've got an atom, we're trying to remove one electron from it. Okay? And well, so let's have a look here. Ionization energy in joules per mole. So we can't just look at one atom, we're kind of looking at a mole of atoms. So let's take a mole of hydrogen atoms. As we can see here, it's going to take 1300 or 1300 kilojoules of energy to remove one electron from every hydrogen atom in a mole of atoms. Okay, so that's a lot of atoms. Removing one electron from all of them, it's going to take this much energy, which is quite a bit. That's about a large meal's worth of energy. So we're interested in the trend, and let's try and see some things. So first off, what takes the most energy to remove? Like which atoms take the most energy to remove an electron from? And as you can see, it's these white atoms up here. The helium, the neon, the argon, the krypton, the xenon, the radon. Because these are our noble gases. They've got a full outer shell of electrons, their valence shell is full, meaning they're very stable. So they're not going to want to lose their one electron easily. It's going to try and hold on to it, and hence it takes the most amount of energy to remove one electron from helium and neon and argon because they're so stable. They're very stable, they don't want to lose their electrons because they have that full configuration. Now, conversely, let's look at what atoms are the easiest to remove electrons from. And you'll see it's these ones in red. It's your lithiums, your sodiums, your potassiums, your rubidiums, and your cesiums. These are group 1 metals. Okay, so lithium, sodium, potassium, these are in group 1 of the periodic table, and they've only got one valence electron. Because they only have one valence electron, it's relatively easy to remove that one electron, because by removing that one electron, they gain the full outer shell. So you often see lithium 1 plus ion, sodium plus, potassium plus, because when you can remove that one electron, they become the stable ion. Okay? So it still takes energy, it just doesn't take as much energy to remove them. Okay? And so this big jump here, let's go from neon, which is element number 10, to sodium element number 11. You got this big jump, and that's because here you're going down in energy level, or you're going down an electron shell. Okay? So this is our second electron shell, this is our third electron shell. So all these atoms in a group, this is in a single electron shell. So this is a 3, 4, 5, 6, 7, 8, 9, 10. This is all in the second electron shell. And as you can see, it goes steadily upwards. Because as you add more electrons, it's going to take more energy to remove just one of them. Until you get to neon, which really doesn't want to lose one. And like fluorine's really close to gaining that full electron shell. It's got 7 valence electrons. It's going to become stable if it gains one, but it's not going to become stable if it loses one, meaning it has a high ionization energy, which again is the amount of energy it takes to remove one electron from every atom in a mole of atoms. So we go up. Here are some notes for you to write down. It's quite a bit, but it's like maybe 4 or 5 sentences. Down a group, which means down the periodic table, there is a decrease in ionization energies. So what do I mean by that? Let's look at neon going to argon, going to krypton, going to xenon. You see how it goes down? Neon's the highest, argon's the second highest, krypton's the third highest, and it just goes down like this. Same thing's happening with lithium, and like here, it's going down. So as we gain an electron shell, which is what we're doing here, let me just switch to my pointer tool. As we gain an electron shell, it's taking less energy to remove that one electron. That's because As you gain an electron shell, the electrons are now further away from the nucleus, meaning it has less attraction towards the nucleus, making it easier to remove. I think that's what I put down. Yeah. The electron lost is further away from the nucleus by an extra energy level or shell of electrons than the element above. There is more shielding by the increased number of core electrons. So, shielding. What do I mean by this? You've got a positive ball of protons in the center of your atom. And what the electrons are doing is they're orbiting that atom, and the core electrons, the electrons further inwards, are shielding some of that positive charge from the outer electrons. So the inner electrons are shielding the nuclear charge from the outer electrons. So when you have an extra shell, you've got increased shielding because you have more core electrons. This results in a decrease in the electrostatic attraction between the nucleus and the valence electron being lost. So less energy is needed to remove the electrons. So there's two reasons why there's the decrease down the group. The electron lost is further away, because if you remember atomic size, it's bigger as you go down the group. But there's also more shielding, so you need these two reasons if you're writing an excellence answer. Across a period, the ionization energy increases. As the atomic number increases, so does the number of protons in the nucleus. Okay? So magnesium has more protons in the nucleus than sodium. Sodium's got 11, while magnesium's got 12. So there's more protons in the nucleus, and the electrons are being added to the same energy level with no additional shielding. Because there's more positive charge in the center of the atom, there is the stronger electrostatic, which means positive to negative attraction, between the nucleus and the valence electron being removed. And so more energy is needed to remove the electron. So to get excellence writing about this, you'd need to say that there are more protons, which means there's more nuclear charge, and there is no additional shielding gained by the extra electron, since magnesium's got one more electron as well, but it's in the same electron shell or electron energy level, meaning it's not shielding the electron being removed. Hence it goes up. I think that's where I'm going to leave it for today. Tomorrow we're going to talk about why it dips. Okay? But the video's probably got long enough already, so I'll see you guys tomorrow.